this episode of Finno-Greek machining, we are going to make a tool. It's like this. It's a composite tool. It has two parts which you can separate, and this one is made out of two parts. This one is hard tool steel, HSS, and the rest is just cold rolled mild steel. And this part is all cold rolled mild steel. And then we have in the tip, we have something like this. So you can rotate it. It's like a screwdriver there. And then we have this kind of thing. Well, this tool is specific for adjusting lathe kips in Weiler. I'm not sure if it works in other lathes, but this one it works great. Let's meet in the lathe and make this. This chuck is unsuitable for the task in hand, so I changed it. After vacuuming it, I will loosen the bolts, putting a low gear and back gear in order to get the nuts loose. Then I just loose them and some hammering, because it's sitting quite tight in the taper. When it finally looses like this, then I can just take it along. Oh wow. It's quite heavy. Yeah, my friend. And after that, the taper, I always take good care of that one. You have to clean it. And then the ways also, because they are now a little bit visible. There is some gunk already. And this hard stop also seems to collect stuff under it. And you can get quite easily rid of it. Just some towels and clean up. Well, now let's put another type of chuck. This is a 4-jaw chuck as well, but it is self-centering. Here I'm watching that it's oriented in the correct way. I couldn't turn it because the gear was too low, but after setting it up you can easily turn it by hand, and then this way. Okay. And you have to put everything in suitable place so it's easier to put in there. And there you go. And then just turn the bayonet when it now turns a little bit, and it is held in place. And then I need to tighten the nuts. First I put them quite loosely, like this. And when all four are loosely tightened, I will then tighten them properly by putting this in back gear by low gear. Here you go. That's low gear, and then back gear. And then this ensures that every nut gets about the same torque. And it's not that hard if you know what you are doing. There you go, that was the last one, and then I check every nut one more time so that they are tight. I don't want this chuck to take a hike while I'm doing things. The Apron has an oil bath, and it is leaking somewhere. I don't know where, and so I have to add some oil into it every now and then, something like once a week. Not much. This time it has been 2 weeks, so I need to add a little bit more. And the oil I'm using here is heavy gearbox oil. It's really heavy. It is my hope that it doesn't leak that much when it's thicker. But that I don't know. It could actually make things worse because this oil is climbing in the gears and so on. But anyway, better this oil than no oil. This here is a spot drill. I'm spot drilling this stock, which is some scrap metal I found in my pile of scrap metal. Probably some project that didn't go that well. Spot drilling is probably the best way to ensure that your drill starts straight. You could use center drill, but spot drill is better. This is an ordinary 4mm drill, and I will make a semi-deep hole with this one first, because the next drill will be a little bit longer. I try to put it straight into the chuck, and there you go, drilling a 4mm hole, which is, I don't know whether it becomes straight. I really hope so. Now, this is a little bit longer drill than normal. It is designed to cope with deep holes. The chip evacuation should be better with this one, but still I'm doing back drilling in order to get the hole straight. Hopefully it is straight now. And after drilling that hole, I will still do one more thing. I will put because we are going to put the live center there. I will have the edges of this hole done with this live center. So we have a center there actually. Here I am approximating the position for the hard carriage stop. You just place your carriage in the place where you want it to stop, and then you put the stop at that point, tighten it, and after that the carriage will stop at that place every time, freeing you from measuring and looking and trying to stop it somewhere. Here I am trying to make this workpiece a 12mm rod. I'm peeling 1mm at a time at this moment, and after doing the rough peeling I will do 2 similar passes at the end. This is the last cut, and I want to make sure that I don't overdo it. So I stop it after a few millimeters and then take a measure. And by this way, if it is now going to get undersize, I can still correct it and the workpiece is not lost. Well, I have learned to do this way because I have overdone this so many times. At the end of this thing, there has to be a 10mm in diameter portion, which is then matching the nuts of the gip tightening system. Swapping over to the collet system. So first I will remove the workpiece. Yep. switch off the lathe. The lathe shouldn't be running when you are dealing with the chuck. It takes some time to shut down, but eventually it will. And now I'm again cleaning the jaws, the chuck, and after that I will just it's a very similar process when I did the big one, but this is a lot easier to handle and you can lift it by one hand. And then of course the taper, there is a Morse 5 taper inside there. It has to be clean now, really clean. Usually it is always clean, but now I ensure that there are no chips and no chips in this either. And I always put this piece in a certain orientation. You can put it in any orientation, but I try to ensure that I don't have a run out there. And now I'm hammering it in like that. And after that I put the nut there just loosely. It protects the threads there. And then this is the drawbar for the collets. You put it through the hole in the backside, and then I choose a suitable collet, which is in this case 12 millimeters. And where is it? Okay, does it fit? Oh man, it's a little bit tight. Okay. Maybe my rod is a little bit oversized. And then you just put the workpiece in and away you go. Here I'm peeling off the scale from the thick part of this tool, and after that I will remove stuff from the end of this. There is, because this is some crap, there will be quite a lot of, there is a hole which is not in the center, and therefore you need to make it flat before you can even think about center drilling this one. And there you go. This insert is a little bit tougher. It tolerates better the zero radius cutting when you go down to the center of the workpiece. So therefore I will do the last mile with this one. Well, this is the spot drill which I will start the process of making an 8.5 millimeter hole which is almost through the entire workpiece. Well, it must be absolutely straight because there isn't not much material at the end of this workpiece. Next drill in this process is an ordinary 8.5 millimeter drill. I will drill it well as deep as it easily goes, and the purpose of drilling with this one first is because this drill is shorter, it is also a little bit stiffer. So therefore we get a straight starting hole for the longer drill. This is now the long version of this 8.5 millimeter drill. It has a Morse 1 shank, and then I have a Morse 1 to Morse 2 adapter, and yet another Morse 2 to Morse 3 adapter. Well, then we have the drill in the chuck or in the tailstock. Now I'm actually just marking the depth of hole there, and then we just drill the hole. Even though this drill is designed to drill deep holes, I am still doing peck drilling here. It keeps the hole straight and keeps the drill from jamming into there. So far this workpiece is now ready, and the next workpiece will be the rod that is put into this inside this tube we now have, and it will be made from a 10 millimeter cold rolled mild steel rod. Well, after setting up the tailstock support and the hard stop, I will now turn this down to 8.5 millimeters or a little under, because it must have room to rotate there. It cannot be exactly, because then it would certainly jam into the hole. Drilling a 5 mm hole at the end of this rod. There will be an HSS tool steel rod, silver soldered or brazed into that hole. The gip adjustment locking nut has two 2x2 mm slots, and this tool should have the corresponding male for that. Well, here I'm doing it. I'm milling 4 mm, 2 mm deep from each side of this workpiece, and then you have that male part. These flats are here just to be able to use a 15 mm wrench in case somebody had tightened the locking nuts too tight. Okay, so this is the compound of my lathe, which has its gip adjustment with these. There is one which I have replaced with a cap screw. This I am using to lock this compound. Originally it has 7 of those. And I used to adjust the gips with this type of tools. And for example, I modified these nose pliers in a way that it fits into there. And as you can imagine, it's very awkward to use these. And then with a normal screwdriver, by the way, it has a tapered tip, and this is bad for the screw there. Okay, so no more that stuff. Now we are using, now I'm going to use this new tool, and it's quite simple. You just adjust, you get rid of the chips for the first, and then you can push this in like that. It goes there, and then you can loosen the surrounding nut. And then by this handle you can then you push it gently and you find the screw there and you can adjust it. And then you retighten it with the same tool, and there you are, it's done. And very simple, and you can control the tightness quite well. Actually this handle is it doesn't need to be bigger than this one because the tightness you are going to tighten is quite quite low. If it would have more leverage, you could lock the entire compound with these quite easily. But this one is good. I could probably put some rubber tube on top of these, but yeah, I can use it as it is now. Okay, so this is the tool, and well, it works great, really. And now I don't butcher the gip adjustment things anymore. So this is now a good thing. Well, in the next episode of Finalizing machining, hopefully we finally get to the rotating welding positioner. Hopefully I get the motor. Yeah. Well, till next episode of Finalizing machining. See you!